So good afternoon. Today I just wanted to talk to you about one clinical trial that is taking place and starting here in Australia. There's one site for this clinical trial starting in Melbourne, and it's a clinical trial using this molecule called RT8408. So this is just a snapshot of a website called clinicaltrials.gov, and I really encourage you to go and have a look to this page because there's basically all the clinical trials that are set up through the US and going anywhere else in the world are listed in this website. So if you want to know any information about any clinical trials that you can think of, you can just head to this website, and that's really useful. And this is the page that is related to the RT8408 that I would like to talk about. So I just copied and pasted from the website how the clinical trial is actually described in the website, and I just read that with you. That's the sentence about RT8408. Studies have demonstrated that the nuclear factor erythroid-derived 2-related factor 2NRF2 signaling is grossly impaired in patients with FA. Therefore, the ability of RT8408 to activate NRF2 and induce antioxidant target genes is hypothesized to be therapeutic in patients with Friedreich ataxia. And that's really nice. I mean, it's a description of what the molecule does, but I don't think it's really accessible to everyone, and I think it would be nicer to have a clearer explanation of what exactly is behind it. And so I thought I could just make a series of little cartoons which are really simplifying this concept, but I hope that they can really help to kind of explain a little bit better what the molecule does. Oops. So I just started from the drawing of a cell, and this is the cell nucleus with DNA. This is all the cells set up to produce proteins, which are basically the bricks building up the cells and all our body basically. And these are mitochondria. And I like to explain what these different organelles are with these drawings. So the nuclei is probably well represented by the part that has the idea of how the cell should work. And then here I put in the protein making chain, I just put a worker working on making up proteins, and in this case I compare the proteins to bricks. And the mitochondria, I compare them to factories producing energy, because that's the role of mitochondria in the body. So what happens? So in the nucleus, there's this idea of how all needs to be set up, and it's basically the place where all the ideas come from. And what happens, I try to just represent it as the nucleus send out a little booklet on how to build up the different proteins. So I just represented it here as a little booklet with the drawing how to build up a brick. And then the workers basically go through the booklet and build up what's written there, and then distribute. So they create the bricks in this case, and then they distribute the bricks to anyone or anywhere they're needed. And in this case, they need it in the factory, so in the mitochondria. So what happens in Friedreich ataxia? I just come back to the nucleus because that's where the mutation for ataxia is located. This is the physiological frataxin gene, and the frataxin gene, as you know, is the gene that is affected in FA. And I just represent it with these green blocks. What are the parts of the DNA that actually build up the little booklet? What happens in FA? This is the FA gene. There is a mutation, which is an expansion, so is an elongation in this site, which is not one of the sites where we actually explain how to make up the protein. But it's a little site that is basically between the first one and the second green block.